Hi everyone. AI is everywhere today, but sometimes there's a confusion about what AI is, what machine learning is, how they relate to assistants and agents. So in this video, for the absolute beginner, what is artificial intelligence? What is machine learning? And how does it relate to all this generative AI stuff we keep hearing about? And when I think about artificial intelligence, or AI, it's really as simple as it sounds. It's software that is exhibiting human-like abilities. So what are the types of human ability that we have? Well, we have the ability to see things and understand what we're seeing. So I could think about vision capabilities. We have the ability to have conversation. I can understand text. So I see something, I can read it from an image, I can point out words. So we understand things like text analysis. And as we have all these different types of inputs, things we see, things we hear, questions we're asked, well, I can do things like I can make decisions. And it's just some of the examples. But if I think about it, it really boils down to artificial intelligence is just software that is exhibiting some of these and more than these types of human-like abilities. So it's really what it boils down to. Now, what then becomes the question is, well, how? How do we have this software that can exhibit these human-like abilities? And one method we can do this is we can just, as the human beings, write a series of rules. We're writing the program that enables these capabilities. So what I'm going to do is I'm just going to create a whole bunch of rules so it can do this. So if imagine was I'm trying to classify a picture, well, I might try and say, well, does it fit within this mask that's a circle? And then I might say, well, what's the color within that mask if it matches that particular circle? So is it red? Or maybe I can start to classify things. If I'm looking for letters or numbers, was it a straight line and then another smaller straight line? Is there a second straight line? So one of the challenges when we try and create artificial intelligence by us as humans just writing a series of rules is it gets hard fast. So it gets very hard to actually, for these richer sets of scenarios, writing all of those rules. We end up with huge amounts of these logical statements, decision trees, and things like that. But the scale hits a certain problem. But certainly, some artificial intelligence is exactly this. Early chatbots, they would take what we typed in and look up certain keywords, and it would have a set of responses. Diagnosis systems would look up from a huge library and, hey, this is the response it's going to get. But it really does have a limited scaling factor. Those things I talked about, trying to detect letters and numbers and reading words, trying to understand what's within a picture, for example. This gets so complicated to be able to write all of those rules. Imagine trying to write that piece of software to detect the difference between an apple and a tomato. Hey, it needs to fit within a circular mask. Apple and tomato both do that. Is it red? Apple and tomato both do that. Does it have a green bit at the top? Yep, they both have that bit flat. It gets very, very complicated. So that's why the next thing we look at is machine learning. So with machine learning, it's a different color. It works in a very different way. And in a lot of respects, it works the way we work as human beings. Machine learning is all about the idea that what we are writing as the human being is an algorithm. So we write some algorithm. And then what happens is the algorithms that we've created can be used to discover their own patterns in the data that we provide it. So we don't tell it how to do the thing. We create these algorithms that can be trained to then be able to perform a certain function. Now, there's a huge number of different types of machine learning model out there. There's a huge number of different ways in which we can use this. But generally, they're all focused around the ability to learn. We give them some input, and they learn during their learning phase. And then once they're trained, their learning is complete, well, then I can give it new sets of data, and it will come out with a prediction, a classification. Hey, is this okay? And so the first type, when we look at machine learning, is going to be supervised. So we're going to come up over here. And this is probably going to be most familiar to us as human beings. It's what we did as babies. Maybe we still do in some ways. Because as babies, how did you learn? Well, people would show you things like this. This is what? It's a labeled piece of data. So it's got the thing we're trying to learn, an apple, and it's labeled as an apple. So there's a text modality to it. We also might say the word apple. So we're doing multiple modalities, a text and an audio modality. So we're saying apple, and we would say tomato. You might pronounce it differently than me, tomato. But we show them these labeled sets of data. And that's the key thing. So what we do with supervised is we have a whole set of labeled data. And then what happens is, just like what our brains do. So what do our brains do when we're showing it these apples and tomatoes? Well, our brains are made up of billions of neurons, and there are synapses, the connections between those neurons. And as we learn, those synapses get different strengths and structure. That's how we learn things. So we show it lots of data. We show it lots of different pictures of apples. Apples in different lighting conditions, partial bits of apples, different types of apples. So we would learn, oh, all of those things are apples. Lots of different pictures of tomatoes. Obviously, it's not that important to know the difference unless we're making pizza. But we get lots of labeled data. And then once we've shown it all of this labeled data and it's trained the model, then we can show it unlabeled data. So we'll just show it a picture without a label on it, and it would now be able to predict the most probable label based on all of the training it has had. So obviously, the better the training data, the better it's going to be at predicting correctly for new data. And so this is all about supervised. Labeled data goes in, we train the model. Once the model is trained, then we send it in new data that it will predict for. And we're going to see that in a lot of different types of applications. Yes, image classification is one of them. But I think about fraud detection. We can start to learn a pattern of this is a good transaction, this is a bad transaction. Then we send it a new transaction, and it's learned what is likely to be a signal of a good and a bad. Should I approve this loan? Predictions on pricing. Based on these inputs, what would be a good price for this house? Medical diagnosis, sentiment analysis, and much, much more. So this is a huge branch of machine learning. And then another one is unsupervised. And just as the name suggests, with unsupervised, what's kind of happening here, let's clean that up a little bit, unsupervised, it's unlabeled data. So what's happening here, we're just sending in unlabeled data, and it is going to find the patterns. So now we're just sending in this unlabeled, and it is going to find patterns. So it's just going to look at all of these collections of things, and it will find, hey, what seems normal? And then it can spot things that are outside of that. So think about monitoring equipment. health of services. It knows what the signals normally are. It learns over a period of time, and it could spot things that are outside of some threshold. It could also be useful for if I want to segment certain entities. So if I had groups of customers, well, maybe I want to group certain customers together that have similar interests, then I as a company could present the right type of marketing. That same type of segmentation could be used, maybe it's a libraries of documents. They're not tagged, but I still want to be able to group like documents together. So this is a very popular type of machine learning as well. And then we have the idea of reinforcement learning. And I think we've all experienced this as well. So the AI interacts with its environment, and what we're going to do is give it rewards. We will reward it when it does the type of behavior that we want it to perform. And its goal is to maximize rewards. That's how it's been designed to perform. I'm doing the same thing with my dogs right now. Sit, hey, have a treat. We're reinforcing the behavior we want them to do with a reward. So that's used a lot in robotics, game artificial intelligence, autonomous systems. So you might have the game, the AI playing itself to improve. Well, hey, it gets more points. That's the reward. It's going to reinforce that behavior. I have a robot that I'm trying to get it to teach to learn to grab something. Well, I give it rewards when it grabs that thing correctly. Maybe I could use it to change prices based on demand. So when there's dynamic circumstances, so that robot trying to grab the cup, it's a dynamic circumstances. Changes in demand on the situation, hey, automatically changing the price. Maybe optimizing my HVAC system based on temperature and spend and optimizing those things. Now, there are other types, but these are really the three main types. When you hear machine learning, it's all about, I'm not writing the specific rule to drive how it does the function. I create the algorithm as the human being, and I feed it in data for its training. So supervised, it's labeled data that goes and trains its model. Unsupervised, it's unlabeled, but it finds its own correlations and patterns between it. And then reinforcement, hey, it's going to go and be rewarded when it does the right type of thing. And each of them have their own strengths. So when I think about where these things are fantastic, so supervised is really good for prediction. Unsupervised is really good for exploration. I've got some sets of data I don't know. I want it to go and find the great things. And then the reinforcement is really good for decision making, especially in dynamic scenarios. So we have these different capabilities. So this is when we think about machine learning. These are the key things we're going to see. This is what we're using for most of the things we have historically done and still do related to artificial intelligence, because I don't want to go and write a whole bunch of rules. It's very hard to do. I would much rather write these algorithms and then give it data so it can be trained. Now, what we're seeing over the last couple of years is a new type of AI experience. These predicted things, they could help explore, they could do decision making. But what we're now seeing, and a lot of it does build on this idea of supervised and prediction, but it does call into some of these other ones as well. What we're really getting to right now is this era of generative AI. It's actually creating. It creates text, images, audio, even video, based on some fairly simple natural language input. We call it a prompt. So we give this a prompt, and then it goes and creates. Now, it could be summarizing a document. It could be creating something from scratch. It might be brainstorming with us, whatever it is. But it's generating content. Now, when I think about these generative AIs, they're nearly always based on something called a neural network, which is based on the way our brains work. So I said our brains, remember, have all of these neurons in them. billions and billions and billions of neurons. I'm not going to draw billions and billions of anything. And then I said there are the synapses that are all the connections between them. Well, what's happened here with a neural network, it copies the idea of the brain in a large way. So we have this neural network in the computer, in the software. And the way this works is we feed it in a large body of data, its corpus. Now, when I think about what this is, you could think it as books, things from Wikipedia, code repos, crawled web pages, Reddit content, social media, whatever. We take this huge body of knowledge. And what we're using here is we feed it in to our neural network. And then what it runs through is a training phase. And what the training phase is doing is it's changing the weights of the strength of the connection. There might be a certain bias, so this one gets a stronger number. So based on all of these inputs, these millions and billions of pieces of text, which are actually converted into subparts of the word that are known as tokens, because computers like to work with numbers, not words. So we just split the words into these tokens that the computers understand. So we train this neural network on huge bodies of text and maybe images, maybe video, maybe audio. We can do different modalities. And it trains. And over that training period, which is very expensive computationally, it's why you hear about these big GPU farms that are really good at working with these numbers that make up all of the tokens that then drive these parameters. So that they get modified, they get tweaked as it builds these stronger connections between certain neurons, just like the way our brains and those synapses grow as we learn tomato and apple. And there might be hundreds of billions of these parameters. They're called large language models, LLM, which is a generative AI. So this training goes in to train all these connections, these parameters. Now, once it's trained, it becomes read-only. It doesn't learn anything new. So we go through this training phase with this whole body of data, and then what we get spat out at the end of it is this large language model. Now, sometimes you'll hear about a small language model. There's a lot of work being done to create models that are not hundreds of billions of parameters that require these huge farms of GPUs to run them. What's very attractive is we can take these models and run it locally on our laptops, on our phones. So that's a small language model. So they might only have a few billion parameters, so they can run on a smaller device. So then once we have this trained model, well, what it's going to do is I give it the input. So the input, remember, is going to be our prompt. So we give it a prompt, and then it is going to generate a response, one token at a time, and the next bit of the token, the next one, the next one, the next one. If I say to you, we know each other so well, we can even finish each other's, what would you say? Based on everything you've learned over your life, the strength of the synapses between the neurons in your brain, you have probably learned that the most probable next thing to say is sentences. We know each other so well, we even finish each other's sentences. But if you were a kid who grew up on Disney movies, you may say sandwiches. That's not my learning, but you may say sandwiches because of Frozen characters. But if I was to say to you, thinking like a Disney Frozen character, we know each other so well, we even finish each other's, well, then I would probably say sandwiches. Because now the most probable output from my brain has changed because you've given me a different input. You changed the prompt to me. And that's what these generative AI models do. Based on the prompt, they're predicting from a probability distribution the next most probable token, and the next, and the next, and the next, which sounds super simple, but it's incredible sets of capabilities. Summarize documents, creating new ideas, brainstorming, performing research, and so much more. You have these reasoning models that go through different iterations. to plan out. They have a chain of thought. Well, how do I accomplish this task? And then it will go back through and complete that task. So there's really powerful things that you can do with these models. But it's basically taking the prompt that you give it and then predicting what the next token is, the next part of a word, then the next part, the next part, the next part. And it's not just text. So when I think about these, it's very common to have this idea of multimodal. And all that means it's two or more of the different types of modalities. So maybe it's text and image, or image and audio, or text and audio, or video. And it might just be input. So the input allows multiple modalities. So hey, I can send it text and images. And maybe the output is still just text. Or I might combine multiple models together. Maybe it outputs at text and then sends it to a text-to-speech model. They're all different ways I can accomplish tasks. But the whole point is, if you hear multimodal, it just means some element of this supports multiple modalities. So hey, I can ask it, what's in this picture? And I can attach the picture to it and it can understand the picture. Now, a key point, this trained large language model only knows what it was trained on. It knows on this huge but finite body of data, which had a cutoff date. Because once I've trained this model, these weights are set. This doesn't learn new things. And so it only knows what it was trained on and what's in the prompt. And so what we often will do is, if there's additional knowledge we want it to be able to work on, hey, summarize this document, well, I have to give it the document. So very commonly what we're going to do is add additional information to the prompt. You'll hear terms like retrieval augmented generation, RAG. It's just a fancy term for the AI application that's generating this prompt to actually go off to some source of additional knowledge and pull additional pertinent data based on natural language that will help this do its job better. It may also describe certain tools that the model could create a plan and ask me to run for it. And the model is read-only. It has zero memory. When you go and talk to it back and forth, it doesn't remember anything about that. They're stateless. What happens is, every time we're having this multi-turn conversation, the AI app, the interface you're using, is actually adding the past history to the prompt. So it's saying, hey, here's what's just been entered. By the way, last time you responded with this because they asked you this, because you'd responded with this. It gives you the whole chain of the history. You're sending that every time. And that's the context length, how much you can send it in the prompt. And there's a certain amount it can respond with. And there's a whole field around the engineering of prompts and the entire context that goes to make that up. So with this marvelous prediction, we modify the behavior. So sometimes we do this reinforcement as part of the training of these models. So I want it to be able to do different things. One of the most common things we want these to be able to do is to act as an assistant. When it's an assistant, well, it's a human asking it stuff, getting responses back. We also see agents. So with an agent, it's actually typically responding to an event, not a human. The event could be an email arrives. The event could be this social media posts. The event could be a schedule. Hey, every hour, go and do this thing. But it's not typically the human interacting. The agent is acting autonomously in the background, and it's performing its task based on waiting for some event, waiting for some schedule. Maybe another agent to agent, is calling it, asking it to do something. But when you hear about agentic and autonomous, it's about, rather than a human triggering it to go and do something, there's some event happening in its reality that makes it go and do the thing. And that was it. That was the really quick overview of all of those different things. So just think of AI as just software that's performing some human-like ability. Hey, I can optical character recognition. I can see text and in an image and I can read it. I could maybe translate between languages. I can summarize what's in this picture. I can find the tree in a bounding box within this tree. I can help make decisions. But writing the rules in software is very hard to do, especially more complicated things. And so machine learning is a whole field where instead of writing the rules on how to do it, we create these algorithms, these structures that we can then pass in data, and it's trained. So supervised, it's labeled data, and then once it's trained, we can send in unlabeled data and it will predict based on that training. Unsupervised, it can help find correlations and segment like data together, find, hey, new things. Reinforcement, hey, these dynamic conditions, it can help work out, hey, this was the right thing, reinforce doing that right thing. And then generative AI, typically based on a neural network, we give it this huge corpus, this huge body of knowledge, but it is finite that it's trained on. And then once the training is complete, we have to train typically a large language model, tens, hundreds of billions of parameters, but also a small language model, which may be a few billion parameters that can run on our phones, on our computers. So we don't have to maybe go and use something like main big servers or the cloud, so it can run locally. But we give it a prompt and it's predicting, hey, what's the most probable output? And the next one, and the next one, the next one. And because it's fixed in time, it can't learn new things. It only knows that body of knowledge. When our prompt, we give it additional information that it might need to do its job. We might describe tools that it could ask me to go and run and then send it the response as the next prompt. And we have to give it the history. It doesn't remember anything about us. We can interact in different modalities, text, image, audio, video, depends on the model. And typically we'll see assistants where we're interacting with the generative AI to help us do the things we do. Agents is rather than a human triggering it to do something, hey, there's some event, maybe some schedule that will make it go and do it. So I hope that helped. As always, till next video, you take care.